Hello everyone, my name is Fabian Hemmer and I am the Chief Development Officer of Droplet Computing. And I will lead you through the technical part of our talk. So here's an overview of our container. So in the container, as you can see on the top, we both run a user application and we also put a kernel in there. So we also put Linux or Windows in there. And in most cases, we intend to put Linux in there. So that is our primarily goal. But if more compatibility is needed, we can also work with Windows. And then optionally, we can also put Wine in the container. That's an option to run Windows applications on Linux. And I will also talk more about that later. And then from each of these three, we take the machine code. And from the kernel, additionally, we take sort of high-level hardware calls. So we take file system calls, we accept network packets, and we also take GPU calls. And I will talk about these a bit more later, how we do it on such a high level. So we take those things into our container, and then we translate them sort of into calls to the APIs that browsers provide. So in particular, from the machine code, we use that through WebAssembly to execute it. The GPU calls we translate to WebGL, and then we handle file system access and network access. Depending on how browsers provide these, so browsers are a bit restrictive, but they can be made to work.
So this runs in the browser, or it's using the browser as like your
It runs
screen?
In the browser.
So it runs in the browser.
It runs in
okay.
the browser, yeah.
You're using WebAssembly. That's brand new, isn't it?
That's brand new, yes.
Still an evolving standard, or is it settled?
The first version has been settled. It won't be changed anymore.
Okay, so can you just explain for everybody how WebAssembly works kind of from a high level?
I will get to that. I have
Okay.
a slide on that. Yeah. So this is just the overview, and I will get into the things a bit more deeply. So what problems have we overcome, and are we overcoming with this? So the browser APIs are quite different from directly talking to hardware, and they're also quite differently from talking to an operating system. So, and they're quite limited, and the browser environment is also limited. And this is sort of a curse, but it also is a feature in a sense that the browser is a sandbox, right? It's very hard to get out of a browser, to exploit a browser, to mess with the device. And we like that because it provides this layer of security. But at the same time, we have to work with the APIs that the browsers provide us. I think we got that working pretty well to most degrees. And then we want to run Windows applications in our container. But we want to do that without Windows in most cases. So a Windows image is pretty large. So we basically target Linux in most cases. And then we don't want to have a classic virtual machine. We want to have the fixed disk that you allocate and the fixed memory that you give to a virtual machine. And we want to be more like a container technology where the RAM and the disk space that an application uses is actually the same on the host machine, and it's not pre-allocated and it's not fixed. So I will quickly talk about Wine before getting to the other things. We use Wine, and Wine is an application and a library in a way. So it's an application in the sense that it can load a Windows executable into a process on Linux. So it takes the Windows executable format and can load that into a Linux process and link it. And it provides the Windows API. So Wine has an implementation of the Windows API, of the Win32 API. In terms of Linux APIs, in terms of the APIs that Linux provide. And Wine has a slightly bad reputation for not really working with many modern applications. But we think it has caught up quite a bit in the recent years. And in particular, we found that it can run modern Office suites, and it has the modern Windows APIs like DirectX 11. And at the same time, it's compatible with many old Windows applications. So Wine has been built up from the ground to work with the oldest applications first and providing the oldest Windows APIs first. And some people even say that Wine is more compatible with old Windows applications than Windows itself.
What about applications that aren't using the Win32 API properly?
Right.
Yeah.
So it can use Mono. So .NET can be made to work, although we haven't tested too much with that. But at least Office works, so that we know.
But some of the, from what I remember, some of the programs that were probably more graphic focused wouldn't necessarily use Win32 correctly. They bypass
Right.
GDI.
in order to get the performance out of it. So
Right. So Wine implements all the things that are implementable. So it also has some of the kernel APIs actually. Some of those can run some of those applications at least that use the Windows kernel APIs directly. But not everything, of course. And for that, we also have the ability to run Windows directly.
You mentioned there's a sandbox environment. That's a term that's very familiar for me with other technologies. When a user makes a change to where an application functions, where does that get stored? Is it inside the sandbox?
Yes. So I will get to that later.
Okay.
Right. And then to continue with Wine, it also has a not so good reputation for being quite bare and not being very usable by non-technical users. And in particular, it's mostly a command line tool to launch Windows applications. But that works for us since we are containerizing applications. So we can just configure the right Wine configuration and put it into the container, and also provide the same environment for Wine to run in. Yeah, and then Wine can be deployed on quite a small Linux image we found. So you don't need to run a full, say, Ubuntu desktop environment to have Wine in there. It just has its libraries, its implementations, and it needs a graphical environment. But it can, for example, be deployed on a small Alpine Linux image. And then we're looking to work, or we're working on integrating with Codeweavers, which is a company that has done a lot for Wine compatibility and for finding the right Wine configurations for many applications. So we can also integrate that potentially. Okay, so let me quickly talk about the browser platform and why we chose it. So the two most important pieces of the browser platform that came along rather recently are WebAssembly and WebGL. So those are the new APIs that browsers provide for us to run our container in a browser, which you would not usually think to be a platform to build this container technology in. And then besides those two, it has a lot more APIs available these days. So there's a lot to integrate our container with, and we don't use all of these. We use some of these, but these gives you to a certain degree an idea of what is available in a browser. And then browsers are everywhere, of course, so that's an interesting target for that purpose. And browsers are also sandboxed, and they also have these sandboxed APIs like WebAssembly, where inside of the WebAssembly module, it's another layer of sandboxing, and I will also get to that in a second.
So does any of this need any of the sort of virtualization instructions on the processor to enable them to work properly, or are they sandboxed in such a way that you don't need to do that?
The latter. So they're sandboxed in the WebAssembly module.
Right.
Okay, so about WebAssembly. So WebAssembly is quite a new technology, and it is sort of a low-level machine language that has been designed by all the major browser vendors and that is standardized, and that is also shipped in all the major browsers today. And it maps closely to machine code, to x86 and to ARM. And it is sort of a subset of the common CPU architecture. So in that sense, it can be efficiently compiled to both x86 and ARM. It doesn't have these complex instructions, for example, that x86 provides. It only has instructions that are also instructions that are efficient on x86 and ARM for sure. Yeah,
Sorry,
Yeah.
when you say it's compiled, is it compiled server side or is it
no,
compiled just in time like JavaScript on the
It's,
browser?
it is compiled by the browser to machine code, just in
Okay,
time.
so it's on the server side, it's just delivered as over HTTPS to the browser.
No, we generate WebAssembly
Okay,
in the browser, and then the browser in turn generates native code from the WebAssembly.
okay, inside the browser's exe or sandbox,
Yes.
essentially. Okay.
And WebAssembly has been found or has been designed to be quite fast compared to native code. So the designers have done some benchmarks where they compiled C program to native code, and then they also compile it to WebAssembly and run it in the browser. And they found that it often runs within 10% of the speed of the native executable. And then WebAssembly is designed in a way where when you generate a module of WebAssembly, that itself is isolated from the browser environment. So it is possible to generate an isolated WebAssembly module, and you have to link manually what calls this module can make. Yeah, and I think WebAssembly is very well designed. I would recommend to read the paper that the designers wrote. And in particular, the designers of WebAssembly found a way to map memory accesses in WebAssembly one-to-one to memory access instructions on x86 and ARM without a bounce check. So they don't need an extra safety mechanism, a manual check that the WebAssembly module accesses memory outside of the places that it is allowed to.
So if you're using WebAssembly, why can't you run x86 apps on an ARM or vice versa?
We can do that.
You can? Because I thought earlier.
Just not vice versa. So we can run x86 applications on ARM, but not ARM applications.
Okay, good. Okay, thank you for clarifying.
Yeah.
So I could use this to run Internet Explorer 6
You're crazy.
so that I can access all of the websites that no one wants to upgrade because the enterprise has this stuff which requires
All the
ActiveX
Java
and
stuff, yeah.
stupid.
You could run it from within Chrome.
So I can. We heard you like browsing, so we put a browser in your browser so you can browse while you browse.
Yo dog.
Yes.
Or could you run 16-bit
It's
applications?
insane.
Yes.
So it'll handle 16-bit, 32-bit, and 64-bit?
Yes.
Okay.
Yeah.
It's not clear to me the question you're asking about this can run x86 apps on ARM. Why doesn't it work in the opposite direction if there's that layer of abstraction?
Because we don't support ARM. We only support running x86 applications. But that's not a general limitation. It's just that
You've not implemented it.
it's not
yet.
implemented yet.
It's on the roadmap, though?
I don't think.
Maybe? We'll see.
Our lips are sealed. You've got to follow where the biggest market is, and the biggest market is
Yeah.
x86, not ARM.
So, okay, that's fair, because like what businesses are using ARM phone apps today as like an enterprise application? But that puts your product more of, you're focused on legacy x86 apps, kind of. Is that fair?
Modern and legacy. The problem is we're focused on production apps.
Okay.
So if they're in production and they're old, it doesn't mean they're legacy. So I think I'm trying to change what people actually call legacy now, because we're coming across people using XP, and it's in production. So it's not legacy. The application isn't legacy because it's still being a production app. So, but if they get more modern apps, we should be able to deliver those as well. But it's a choice, isn't it?
Plus, there's a boil the ocean thing going on here with any new product, isn't it? You could bite off a lot more than you could really chew
Right.
in the shorter term.
No, it's smart.
Yeah. So you might as well go for where the biggest target market is in the short term, and then, as you said, the number of people delivering enterprise applications on ARM won't be as big, but that will only grow, won't it, over time?
Right. Well, the MRI example you opened with was compelling to me.
Absolutely.
I am really concerned about the security implications of this, though. Like, okay, great, I've got an old version of Excel. Does that mean that my enterprise is now trivially pwnable because someone runs puts in a USB stick with macros enabled, which then, yes, there's sandboxing and stuff within the browser, which is designed to restrict certain things. However, we're now,
You're still
web
running a
USB.
compromised version of Excel.
I can still compromise that thing with a macro. So what are the ways in which I can escape into the rest of the enterprise?
That's a question of
or
the
inject
browser sandbox in general. That's how the browser's built.
Yeah, but
this is going beyond.
Yeah,
like,
the
I'm not
browser
just browsing. Like, I'm actually running stuff, and I'm going to be doing things like
But it's within the
interacting with
context of
external
that browser's
devices.
executable.
But you can,
But it's plugged into an MRI, which means I need to be able to talk to hardware stuff.
but you can also argue
That's
that
WebAssembly.
any application delivery mechanism that allows you to use a legacy app, whatever its design, is going to extend all the vulnerabilities of that legacy app
So we're not
because you're choosing to
we're
carry
not
on
Yes.
fixing
using
the
it.
fundamental problem. If security pings me because the MRI app is vulnerable, I'm not solving the problem that the MRI app is vulnerable. So I'm not fixing the core security issue.
But isn't
Well, you're
the
fixing
core
part of it.
security issue not the app, but the operating system
Exactly.
that it's on?
It
No,
might be
Not
both.
necessarily.
Not necessarily. So
That's my concern.
yeah,
Like,
the
is
You're
this
fixing a big problem by getting rid of that old OS,
OS.
but then the app still needs network access in those pieces. Yes, because it's sandboxed within that processor. It's restricted what it can do to the rest of the
I'm
operating.
suggesting the apps we run in the browser today are just as much of a security headache that we should be concerned about, but because we
Yeah, but they
use them,
weren't
we kind of
developed
ignore them.
13, 15, 20 years ago. Like those apps are updated.
Well, because it's being delivered via WebAssembly into the browser's sandbox context. It's
But I think that the point to all this is that you're essentially reducing, you're not eliminating the security threats, but what you are doing is
Reducing
reducing the
footprint.
footprint because you haven't eliminated anything about the application threat. But what you have done is eliminated the potential operating system threat or whatever that application was sitting on top of, because it now is using something more modern.
So the
Yeah, so it is
application may
better.
have had an exception throughout the years. The application will continue to get the exception, but the OS will. I don't have to now do an exception for the OS.
And I don't think that should be underestimated. I mean, the WannaCry incident that
Exactly.
happened last year, it catastrophically impacted on our National Health Service,
including MRI machines that were running XP as the OS.
which is the largest employer in the whole of Europe. It's a big, big organization with a lot of applications that are based on things like Windows XP. Admittedly, not all of those things are necessarily connected to the core network, so they weren't necessarily encrypted and ransomware.
So this is a boiling the ocean thing. The big problem is getting off of 2000 XP. I'll guarantee you that I still have a customer out there that has a 98 desktop because they couldn't migrate it to XP because of this stupid shipping app. So there's even older OSs out there that are required because of the app itself. So we have two layers of problems. The OS is one,
Yes.
the app is another.
Yeah.
Yeah. But I think you're right. If you eliminate the OS, then you've reduced the attack surface to something which is now a macro that's running inside a spreadsheet as opposed to an OS that can be
Right.
yeah.
encrypted. And
But to
made dead.
clarify, are you encapsulating at the application boundary, or do you also carry like a run? Let's say for conversation's sake, let's say the situation was you had an older application running on top of XP. When you move that into the droplet model, are you taking that application and completely encapsulating the application at the application boundary, or are you also picking up like I'm going to use my own term, but like a runtime version of XP as well within that container, within the droplet
You mean
container?
DLLs, various DLLs that are needed by
Right.
the application calls?
So
Right.
the application and the runtime in terms of the operating system are together in the container.
Okay, so back to what I was saying earlier then, it does reduce some of the threat footprint of when I was running completely on XP, but there's still
The
something
operating
that's
system
coming along
is
with
in
it.
there, yes. Yeah.
Yeah, I guess there's a tension there in that improving things is good, because at the moment it's terrible and broken and I'm not fixing it because I must have this application because otherwise my MRI machine doesn't work. So fixing the security problem is not possible without turning off all of my stuff and going bankrupt.
Or
Like,
getting
okay.
a new MRI machine, which is relatively expensive.
Correct. Otherwise I've got to replace everything, which is like, okay, I can't afford to do that.
Yeah.
I guess.
But on the downside is that I've just removed the reason for doing anything. So ransomware is great because it made people back their stuff up.
That's what they said too.
Yeah, people don't fix stuff unless it's on fire. So you've just put out the fire, so now I don't have to fix anything.
Yeah. So just to clarify,
But how much improvement are we getting is what I'm trying to get out,
Well, and
trying to
also,
understand.
to continue that point where you've kind of said you can now go, we've got a way to run these things which is maybe a little bit more secure than running on the old OS, where you're talking about getting all of your old Office XP and Office 2003, suddenly you've just, where you didn't have a problem, you've just opened up a problem with all those things that were vulnerable. I mean, there's...
Hooray!
Yeah, exactly. So you've got that use case of this app is running on a vulnerable and we need to do something about it, and that's there, but we've all moved on to more modern and more secure versions of these apps, and then you go, hey, open all these insecure apps again. So you kind of... That would worry me.
Because people hate upgrading stuff because it's painful and terrible. The security problem has, I think people have finally gotten to the point where they go, okay, I need to patch everything and I just need to upgrade constantly and turn on automatic upgrades for everything because that's how we do stuff now, rather than trying to buy software once that is full of bugs, I just don't know what they are, and then running that forever.
Are you
But the
concerned?
reality is we don't turn on the automatic updates for everything because of the fear of breaking something critical. As you know,
If I shut down manufacturing because I turned on automatic updating, I will get fired. The possibility, if I stopping production is a higher risk than getting ransomware.
Plus, I think we're missing the point here is that we're not talking about mainstream apps like Office XP. Who wants to extend the life of those sorts of technologies? But it's
we
more
are.
bespoke applications. The MRI example is a key one. That is not kind of generic off-the-shelf software, which is probably being maintained at all. I think the other side of things is if this technology was just about legacy apps, that would be a bit of an issue. And I think we have to keep our minds open to this may be a potential way of delivering apps that is not just about legacy, it's about future apps as well.
Which brings us to kind of the runtime for this, which makes it interesting. That I was trying to figure out at the onset, how is this any different than ThinApp and all the other application virtualizations? But this is much more about the runtime than it is about anything else.
But I think, Justin, you said at first about the browser and the sandbox. I personally think the sandbox model is not a very good security model, but that's what the industry's kind of settled towards. So I understand why they would deliver WebAssembly to a browser. That's kind of the state of the art right now, is the browser sandbox model.
Well, the browser is the new operating system in a way.
Yeah.
Well, I see Droplet as basically being a new operating system target that you would write apps to.
But why were you concerned about
because
the
it's the
sandbox?
promise of, well, it's because just the legacy security issue is one thing, but the new operating system target, the promise of that is what Java was, which was write once, run anywhere.
Yeah.
That's what we want. That's the dream, which has not been possible for a variety of reasons. So maybe now.
Well, yeah, I think
But
that's
it's
what
not
WebAssembly's.
perfect. But there are catches depending on how we use it.
I mean, you make a very valid point that any technology that allows you to persist the legacy app means you're just deferring inevitably, then move to something more modern.
But
I mean, and that's the
perfect
kind
is
of
the
a
enemy of the
truism.
good.
That's where it's sort of, it's designed to do that, and therefore it's a criticism that it's doing what it's designed
In the
to do.
case of
I'm
an
okay with progress,
Yeah.
and that's what I'm trying to understand. Is like, if this is progress, yay. But how much progress is it versus, so there's going to be this trade-off. So if I do, okay, I'm prolonging some of my legacy apps, but it makes my security posture better, okay, good. Because otherwise it wasn't going to change at all. So, okay, now I've improved things, fine. But if I'm also, so if I improve here and then I resurrect all of these zombie applications that create a security risk for me, it's like, okay, have I just made the net landscape for security worse?
How does it resurrect applications? I'm missing that point.
Well, from before we were saying you've already purchased all of these licenses to Windows XP and Excel 2000 or WordPerfect 5. So you can spin them all back up again. Whereas I wasn't using them
Assuming
because
that
they won't
they're
run
just
on
gonna
the
Why
stay
can't
there.
you do that?
because I've already bought the, because I already
I
paid
think
for
it's
it. Why do I want
really
to
tied to
subscribe
the
to Windows
MRI.
10 and run new apps?
We actually want people to go to the new versions,
Yeah.
but it's a choice, isn't it? We can't say to somebody you have
Yeah,
to do
but people
this.
make
It's a
bad
choice.
choices.
Yes,
Yeah.
It's a choice.
Or they make
but-
human-focused choices like the MRI machine. If that's a $500,000 upgrade and I can't afford it, this is
Yeah.
a perfect fit for that because you're going to save the cost of that MRI machine, which helps people.
Which is, we're kind of circling back to the thing of the security issue was a great forcing function to stop humans hitting themselves, because this is all, humans are the core of the problem here. Because, and there are economic incentives for not upgrading things because I've got to buy a new MRI machine and that's too expensive, and I won't turn on automatic updates because I might break production, and that's why that's why MES gets completely owned by malware, because they didn't have auto updates or stuff like that.
FedEx.
So it's like, how are we fixing the world? Are we making the world better or worse?
That's more indicative on the security posture of the company and how their security program is ran than the tooling of the product.
Right,
Yeah,
but it's systemic incentives, which is,
I guess I see this as more of a stopgap measure or more of a crutch to help me be able to move in the right direction. It doesn't solve all the problems, but it at least allows me to take a couple steps in the right direction.
Like the early days of virtualization when you would virtualize a old 2003 server.
and put NT4 on new hardware.
And we
case
keep
in
on-
point,
For
some
2
of-
years until I get the
Some of the
thing.
tools today where you can take, let's say we were talking about this, a couple of us were talking about this yesterday, where you can take an application, not a desktop application, but a server application that, let's say it's running on an old version of a server operating system, being able to virtualize that and bring it forward and encapsulate it.
Yeah.
That's essentially what we're talking about for an application here.
And that was
It's
awesome.
not something
that was great.
Yeah.
It was a stopgap, but they were also, I mean, if you think about the early virtualization projects, they were to virtualize that low-hanging fruit, to get those legacy, a lot of them anyway, a lot of the older applications that we didn't want a full server for. This is, and then it turned into a whole industry in and of itself. This has similar potential, it would seem. There's a use case here for legacy, but there's also a whole greenfield opportunity.
That's what I was thinking.
I
too.
bet there's more slides.
Yeah.
I'd be curious.
Give us more slides,
Getting to that point.
more PowerPoint, please.
You're saying
So
stop talking?
what's your performance look like? Because you're compiling in the browser.
Are you going to show us? You're going to show us a video demo, right?
Yeah,
And will that show us some performance information?
yeah.
Okay, I'll wait.
So just a quick word on the sandboxing. We're actually doing things on a file system, on a file level, and I will talk a little bit about that later. But basically what we can do, for example, is we can make the whole container immutable. So you cannot change any files, or only certain folders are synced with the outer host. So I think that also provides some level of security, I would say. And it can also be snapshotted. So if some malware gets into your system, then you can just load the old snapshot and you have all your things back again as they were before. But let's talk about how we actually use WebAssembly. So what we do is we take the native machine code and we recompile it to WebAssembly. And we do a whole bunch of analysis on the machine code to get it into the WebAssembly format and to produce efficient WebAssembly code. So WebAssembly closely matches x86 assembly, but there are a few steps that are necessary to do this efficiently and to allow the browser to also generate efficient machine code again from the WebAssembly that we give to the browser. And in turn, the browser provides a lot of features for us that we don't need to implement. So in particular, the browser is able to generate ARM, and we don't have to deal with anything ARM related because the browser just provides the browser APIs that work the same on all platforms. And then the browser verifies the safety of the WebAssembly modules for us. So it makes sure that there's no sort of unstructured control flow where the application can execute code that we didn't put into the WebAssembly module. So basically, these are on a very low level the steps that are needed to translate the machine code that we receive to WebAssembly. So most simple x86 instructions become also a single WebAssembly instruction since they map very closely. And then for memory accesses, we don't have a memory management unit, so we need to emulate one, unfortunately, because WebAssembly does not yet have the APIs to do this with the help of the memory management unit in the host. But basically, we are able to turn that into a single cache lookup and then the actual memory access in the fast path. So it's not quite the same, but it's one extra step, so the performance is decent, I would say.
So is this recompilation process a one-off event that happens when the application is packaged for the container?
No, it happens in a just-in-time style.
So as in when the application is running, it's
in the browser.
Yes.
On the fly, doing that as needed.
Yes, but it is aggressively cached, so we don't compile the same code twice.
And is the compilation process the thing that makes this not a shim or something like a shim that would act as a translation between two different generations of?
Right.
Yeah. Okay.
You said before that in terms of the memory bounds, that it doesn't need to do bounds checking because I assume that's because of the sandboxing within the browser environment. That that this is safe memory.
Yeah.
Yeah. Some applications use like the inter-process communication between applications. I'm interested in how that happens, which is sort of related to the loading of special libraries and so on. Some of that uses memory.
Yeah. Do you mean in terms of using memory to communicate between the...
As one way, but there are other applications. So when you were saying before that you'd have multiple applications that are related to each other would be containerized together.
Yes.
That means that all of the communications is contained within that one sandbox.
Yes.
Even if it is memory based, it's still so it's able to do inter-process comms through memory within the container space because it's been put into the same sandbox.
Yes.
Okay.
Yeah. Then from the machine code, we reconstruct the original control flow, and WebAssembly accepts this high-level control flow to make sure that the machine code does not have arbitrary jumps into some places in memory. So that way, WebAssembly makes sure that all the code is only all the code that is executed is only verified WebAssembly, and it doesn't jump into some memory location somewhere and execute arbitrary code. And then we do the translation from when native code accesses a register into a local variable in WebAssembly, for which then the browser can in turn allocate a register. So this is also a one-to-one translation.
Why do you need Wine if you're just using WebAssembly? Where does Wine fit into this?
So Wine is not an emulator. That's actually the meaning of Wine. And Wine just implements those DLLs for us. So the Win32 API.
So it's part of the WebAssembly package my browser's pulling down.
Yeah.
It builds up Wine, and that puts the required Windows DLLs in
Yes.
my app.
Yes. Wine is the library.
Can we back up a second. So WebAssembly, I might also packaging, I might also, so basically you guys are running, are you guys actually running the Linux kernel as part inside of the browser?
Yes.
So I'm compiling the Linux kernel.
Yes.
I compile, along with that is Wine. And now I can run my app basically inside that Linux kernel that's running on WebAssembly.
Yes.
So WebAssembly, Linux, Wine, my Windows app.
Just like a PC with assembly code running on the hardware.
Core, right.
And then the kernel loads up and you can share application.
Yeah.
Wine's only needed if you're running it on Linux. If you stick a Windows kernel in, you don't need Wine.
Yeah,
Oh,
so
really?
if you can run the actual app itself without all of the window dependencies that
That's
Wine.
interesting.
Yeah.
But you know, if you think about it, Wine is open source. You know, you can just download it. But then if you go to the CodeWeaver side, if there's enterprises that want sort of application sort of support, that's where you go to potentially take Wine out and put CodeWeavers in with their crossover product. And it's Wine, but with support, and they've got a lot more functionality in it. And it depends on which way if enterprises want to go that way. But the Wine version is just, if you want support for Wine, it's going to be very lucky if you get any. Yeah. But CodeWeavers offer it, so that's where the difference is. But you need to then have a CodeWeavers license.
And none of this would be possible without WebAssembly, which is now mature enough to use.
Correct. Yeah.
Okay.
Yeah.
So the limiting factor here from a compatibility standpoint is Wine, right? I mean, let me explain that. So if an application isn't going to work under Wine, it's not going to work here.
No, we can put Windows kernel in.
So the preference is to run this in Linux with Wine on top because that's a much it's much smaller.
Yeah.
But if it isn't going to work,
okay, got it.
Yeah.
So you can bring the actual Windows DLLs and all that good stuff forward. Okay.
Yeah.
With the code weavers.
No,
no.
with just
Natively.
Windows.
Okay.
Windows
You're going to
inside
take them
of a
from the
browser.
host computer or the DL? All right. I'll
so
trust
do I have to
Draw
run
that
the
in.
app to that point? Can I just
Whiteboard.
run Windows inside my browser?
Yeah.
So I could use that to then be my VDI image almost, and then connect to things.
Correct. Yeah. Linux is really cool because it's really small. Windows is a lot bigger, so you could in fact put XP. If you've got an XP app, you can put XP in.
If I don't even need to launch the app, so I could just have Windows pop up.
We actually do stuff where we say the desktop isn't what people want. They just want the application. The desktop's just there as a tool to run the application. So if somebody's got an application that needs XP, then just run it on XP. If it needs Windows 7, run it on Windows 7. And then if you can run on Linux, run it on Linux.
Could I run DOS 6 on this?
Yes.
Yeah.
Goodbye
can run-
virtualization.
Have you got your original 3 floppy disks?
I do.
I do.
I do.
I have
too,
a
yeah.
5 and a
We
quarter
can do
inch
95,
drive.
98.
But do they work?
Yeah.
The operating system?
Yeah. We can even do OS2. So there'll be something I'll be talking about around OS2. The thing is, it's we get people coming to us and going, can we do this operating system? There is a limit to what we can do. We have turned some away because we're like, really? We don't want to go that old. So.
Is there a mechanism in WebAssembly for digital signatures on the?
There's cryptography. But,
Okay, because my only worry is whatever I'm pulling down over WebAssembly, I want to know that it's authentic and genuine
yeah.
and hasn't been tampered with in transit.
Yes, that is in browsers. Yes.
That's in browsers, but
Yeah.
on machine level code, I want to know it's got a digital signature attached to it.
We
Just wondering if there's
we
a
can
spec.
implement that.
Maybe we need to get onto the demo and actually see
Yeah.
this thing for real.
Yeah.
Yeah, thanks.
So I have one very, very technical slide. So I wanted to show you just a small example of
That's
the kind of
assembly
code that we compile. So on the left, this is C code, but this is not really relevant to us because we don't have access to the original source code of the program. And in the middle, we have this a text representation of x86 assembly, and on the right, we have a text representation of WebAssembly. And one thing you can see is that here, this add and this multiplication and multiplication, it's a one-to-one mapping in x86 assembly and in WebAssembly. So those arithmetic instructions, those compare instructions, those moves between registers basically correspond one-to-one. And then the control flow is a bit different. In those two, actually, the control flow of the WebAssembly on the right is more similar to the one in a high-level language. But we can, there's an algorithm to reconstruct the control flow from this jump. So in the middle, you have this jump where the dot top is some place in memory in x86 from which the next instruction is read. And there's an algorithm to, from that, reconstruct the high-level control flow where you need to have a block that says where you're jumping to, and you don't jump to a place in memory. And then at the same time, WebAssembly just uses this high-level representation for verifying the safety of this module. And a block instruction, as seen on the top there, or a break instruction, as seen on the bottom there, do not actually correspond to code that the browser needs to generate. The browser just needs to verify the safety of this, and then can also generate this lower level representation in the middle. So optimally, in this example, we take the native code in the middle, we convert it to the WebAssembly on the right, we give this to the browser, and the browser is in turn able to generate the same native code that we originally had. So it's a one-to-one translation. And the WebAssembly intermediate representation is just used for compatibility and for safety.
Just from a curiosity standpoint, I have C code there on the left. What is your runtime development? Is it all in C or something else?
It's in C, yes.
Okay.
And a bit of JavaScript, but mostly C.
I desperately want to get to the demo, but I can't help but ask this question. The analogy was made about virtualization and moving legacy OSs into a virtual machine, and the selling point of that was there was no need to recompile the kernel. And by not recompiling the kernel, you weren't invalidating any potential support from the OS vendor, mainly Microsoft, because recompiling of Linux kernels is, for some organizations, something that they just do. So if I have a modern application running in this environment and it crashes, who's responsible for supporting that if you're actually recompiling it? Can the software vendor go, it's nothing to do with us? Or do I come to you guys if that application is malfunctioning?
Well, we would need to test it if it crashes because of our recompilation or because the application is faulty. But if it crashes because our recompilation doesn't work, then that's our fault.
And then the other thing that's associated with that is if there are patches coming out for these modern applications that fix some sort of security weakness, do I need to go through the building of this process all over again every time there's a new patch for that modern application?
Yes, but this building happens at runtime, and it happens invisibly.
Right. I mean, how would I do updates to software? Do I just say yes to them and they just get written to the Sandbox?
Well, we have this container style images, so you would probably take a snapshot of your application before doing it, apply it, and then commit those changes.
Right. Okay. Right. I'm with you. Okay.
So. I want to quickly talk about file system. So we're not providing a block device to the Linux kernel, and instead we're doing this. We're doing it on a file system level, similar to a network file system. So the Linux kernel talks to our container using file system calls such as write this file, read this file, give me which files are in this directory. And this is based on virt.io, which is a technology from para-virtualization, and 9p, which is a network file system. But it's not really a network file system. It's just the interfaces between the kernel and our container. And as it's on such a high level, we can handle the file system. We can split it depending on a mapping of directories. So we can, for example, sync specific folders with folders on the host. We can sync other folders with a cloud service, and we can just load certain folders that are, for example, part of the application or part of the kernel or part of a library from an immutable store, similar to how Docker does it. And yeah, so here's an image of this. So we have this file system manager as part of our container that handles how file system calls are handled depending on which folder they're in, for example.
What about communication between an instance of the application and another application running on the same mobile device? Do you have a certain level of control of what information can leave the Droplet application and what other things it can talk to?
Yeah, it's completely configurable. So folders can be shared between even multiple container images, or they can be separate. And you can let a container view your documents folder and write to it optionally. So such things are possible.
Can that be set through a central policy?
Yes.
I know in situations like Intune or Good, one of their big security things is I can say, good applications can only talk to other good applications, and that information never leaves that sort of shared space.
Yes.
You can do that same sort of thing?
Yeah.
Okay.
Okay, and then about graphics. So far we got the performance in terms of CPU performance. I explained that. But there's also the problem of graphics performance as we want to run graphical applications. And there's also this other technology from para-virtualization that is called virt.io GPU. And it passes through high-level drawing calls, which is based on the Linux Mesa library for rendering. And this library implements OpenGL and Vulkan for guest applications. So applications that use these high-level rendering APIs, such as OpenGL and Vulkan, can use Mesa, and then the Mesa calls will be passed through to our container, which in turn can then translate those calls to WebGL calls. So all of this is sort of on this OpenGL level, because WebGL is also closely related to OpenGL. And then in turn, Wine supports translating DirectX calls to OpenGL calls. So using this, we also support accelerated DirectX.